All right, so today what we're going to do is we're going to go over the team test that you got on the Google Documents, and we're going to try to discuss exactly how to do every single problem. I've also posted the key. It'll be available at noon today, and I'm hoping that this video will also be available at noon today. And at noon today, we're going to be going over, today being Friday, the 15th of May, we plan to go over all of these problems during a live meeting. So there are different ways we're trying to meet the needs of different students, but I wanted to go ahead and make this so that students who needed help would have the opportunity to learn from this video. So what we're going to do is we're going to try to find the volume, the surface area, we're going to try of this object. We're going to need to make a map plan and the top, right, and front views of the object. And we're going to need to discuss what happens if it is made much larger by a power of 6. So one of the things that I did in order to be able to hopefully show what's happening is I went ahead and built the object. Now, it's not pretty and it's not perfect, but this is the same exact object, and I'll talk about why I've marked all of the different sides. But we'll come back to this picture a little bit later. So the first step, and really the very first question on the team test, is to do the map plan. And the reason why the map plan is the very first problem is because that will get you, if you know what to do with it, you'll get the correct answer here every time. And if you know what to do with this, you can do these 3 views really, really easily. So when we're doing the map plan, we really want to know how many objects there are in each of these different stacks. So when I look at this 3-dimensional object, I want to figure out, well, how many are in each stack? Now we can see that in the back on the far right, there are 4. So I can put a 4 here. Then next to that, I see there are 2 in that next stack, and 2 in the stack next to that, and 1 more than 2, so that must be 3. And then when I look in front of the stack of 3, I see there's only 1 there. And then in this stack, there's a hole there, so that means there's less than 1, which means there has to be 0. There's 1 here, and there's none in front of the stack of 4. In fact, there's none in front of that as well. There is another 1 here, and another 1 here, and another 1 here. So we have all of those. In front of this short stack of 1, we can count these up, and we see that we have 5. And then next to that, I have 1, and 1, and 1. So that's the perfect, correct map plan for the team tests, practice test problems. Now I did change the name, and I know that confused folks, and I apologize for the confusion, but it's been a very, very steep learning curve, and I'm literally doing the very best that I can, and I apologize for any and all confusion. But we do have to kind of work with what we've got, and this is what we have. Now, the next question on the test is to do the top, the right, and the front view. And so to do those, it helps if you kind of understand what's going on. And so one of those things that's going on is the top view. Now the top view ends up being the easiest. So if I look over here on my map plan and I highlight all of the places where I have a number other than 0, and you do have to have a number in every single box, but I want to highlight everything that isn't a 0. This is the shape of the top view. It should be identical to what I just highlighted there. So that's what I'm going to do. I see that it goes across by 4, and then down 1, it dips inward, and then back out. And there's also a hole in the middle right here. And then I want to make sure to fill it in because it needs to be clear what parts you mean. If you just put an outline, it may be hard or impossible for me to know that you know what you're doing. Highlighters are great. They aren't always available, but before I highlighted that was still fine. And I apologize for the blurriness. It got better, thank goodness. Okay, so the top view and the map plan are the most alike. The next thing that I think is pretty easy is the front view, because what we want to do is we want to figure out how tall each of these stacks is as we look at it from the front. So if I look at it from the front here on the far left, the tallest stack is 5 tall. And if I look at these numbers, the biggest number is 5. So I'm gonna do all the way up 5. Then I'm gonna look at the next stack. The next stack, the biggest number here is a 2. If I look at it over here, I see that it goes up 2. So I'm gonna go up by 2. And then the next one, I see also that's 2. So I only go up 2. And then the final stack, it goes up 4. So I'm going to go up 4. This will give me the front view. And again, you can just do like I did here, or you can shade it in with a highlighter. It just needs to be 100% obvious that this is the exact shape that you wanted to get, and then you get your credit. Now the hardest part of all is the right view, because basically the picture, we have it, basically we're looking at it, sorry my screen froze, it'll unfreeze again in a minute. So when we're looking at it, the three-dimensional picture is kind of like this orientation, but we want to look at it from the right-hand side. So when we're looking at it from the right-hand side, this map plan is these blocks. 3 in this stack, 2 in that stack, 2 there, 4 there, 5 here, and so on. And so what I really want to do is say, well, from the right-hand side, so here's the right-hand side, I want to figure out how many are there in each stack. So I begin at the very back row. That back row leads me to figure out exactly how many I'm going to have on the far right stack. So that back row, the biggest number is 4. So I'm going to go up by 4 on the far right. Then my biggest number is 1. So I'm going to only go up 1. And then my biggest number is still 1. And then finally my biggest number is 5. And so this is what it's going to look like from the right. Keep in mind, if you can get the map plan, you will get 60% on this test. If you get all these numbers right, if that's the thing you get, you can get 60%. If you know what to do with it to get these, then you're going to get 70%. And if you know what to do with this to get the volume, suddenly you're already at 80%. And that does not even include your work on problems 4 and 5. So the nice thing about the volume is that all we really have to do is add the numbers up in the map plan. So I'm going to go ahead and add each row. So 3 plus 2 is 5, plus 2 is 7, plus 4 is 11, 1 plus 1 is 2, 1 plus 1 plus 1 is 3, and 5 plus 1, all of that ends up being 8. Now what I'm going to do is add these together. I've got, when I add those together, I get 24. So 24, I literally had to use 24 wooden blocks to build this object. That's what the 24 means. But we have to include the units. The simplest way to include the units, particularly if you're taking the test online, is to write units cubed. You don't want to say squares cubed, because squaring is what we do to units. So you want to make sure you can use the the weird unit of blocks if you want, because I called that a unit. But I think this is the simplest one, and it helps you the most. So this right here, now, assuming you've done all of these other ones correct, you now have 80% on this test. Okay? Now the next part it starts to become just a little trickier, and that's why we want to kind of go over it. Now the surface area of the solid is going to be how many squares we see when we look on the top. So how many of these squares do I see? That's one square unit, and I want to know how many I have. So from the top, if I literally add up all of the shaded regions in here, then I'm going to know how many I have from the top. So I have 4 plus 3 is 7, plus 2 is 9, plus 4 is 13. So from the top, I have 13. And if I have 13 from the top, I also have 13 from the bottom. So I'm going to multiply that by 2, and I know that from the top and the bottom, I have 26 square units, or units squared. Next, I want to look on the right-hand view, same technique. The right, if I look here, I see that I've got 5, 6, 7, 8, 9, 10, 11. So I have 11 from the right view. And then whatever I have from the right, I'm also going to have from the left. So I multiply that by 2. The next thing I'm going to do is look at the front. Now there is a trick in the end, so I know this kind of seems a little boring, but we are going to get to the trick after we finish with these. So from the front, I'm going to add these up: 5, 6, 7, 8, 9, 10, 11, 12, 13. So from the front, there's 13, which means there's also 13 in the back, so I multiply that by 2. The only problem here is that there are going to be hidden surfaces. So let's take a look at the object I built. Now, from the front, we've said that there are 13, basically we're saying there's 13 blue squares that are visible. So I can count up these 4 plus these 4, that's 8, 2 more, and then 9, 10, and 11, which is great. That's what we expected from, they're supposed to be 13. I messed it up. I can't count. Yeah, 13. So 8, 10, 11, 12, 13. So there's 13. So there's supposed to be 13 from the front. But what we do is, if I tilt this a little, suddenly you're going to see a few additional surfaces that weren't obvious when we had it like this. Like, we did not see this surface right here. We did not see this surface. And we could not see, really hard to, so we could not see these two surfaces. So they were all hidden behind this tower, behind this piece here, and behind these two pieces here. So if we look at the picture, we can also see where they're hidden there. If we look at this picture, this juts out. There's a little divot here, and that means that this is hidden behind this surface. And there's this one hidden behind this one. And these two are hidden behind, not that one, this one and this one. So we have 4 surfaces hidden from the front. The next thing we need to do is see if there are any surfaces hidden from any other direction. So when I'm looking at this, I'm trying to see, if I look from the right, is there anything that this tower blocks, for example? And when I look at this tower, I see that it blocks this. I'll sort of shade it in to make it look different. So this right here, this block is obscuring or making it impossible for us to see that surface. So that's another hidden surface. Same thing, this block here is blocking, so this hole here has this surface that we can't see also. So from the front, we have 4 hidden surfaces. From the right, we have 2. So we have a total of 6 hidden surfaces from the front and the right, but we also have the back and the left. So we have to multiply that by 2, and we get 12. Now what we have to do is add these numbers together. So when I add these numbers together, I get 86, and my units are squared. And that's going to be my surface area. Now we have to focus on what happens when the object gets bigger. Now if I were to make one cube bigger, what ends up happening is, like if I were to make a single cube twice as big, we can take a look at a single cube. If I take that cube and I want it to be twice as big, then that means that it's going to be twice as long this way, but it also has to be twice as long this way. And it's got 3 dimensions, so it's still not twice as big because I've only made it half as big vertically. So I have to add more cubes. So suddenly a single cube, when I make it twice as big, when I make that cube twice as big, it takes a lot more surface and a lot more volume. So like the surface of a single cube is 6 sides, so 6 units squared. The volume of this cube is 1 unit cubed. But when I make it twice as big, I needed to use 8 different cubes to build it. So the volume is 8 times as big. And the surface area, what was 1 unit square, is now 4 on each side. So it's really 4 times as big. So we have to keep these things in mind when we're trying to calculate these numbers. So when we're calculating these numbers, what we're going to do is we're going to begin with our old volume. Our old volume is 24 units cubed. And whatever we do to the scale factor, we're going to do, to the units, we're going to do to the scale factor. So our new volume is going to be the old one times the scale factor cubed, and then don't forget that you're still going to have the units cubed as your answer. So we're kind of using the units as a shortcut, but you don't want to forget the units for your answer. So I'm replacing the U here with my scale factor. So if this is 6, if my scale factor is 6, then I'm going to take 24 times 6 cubed, which is 6 times 6 times 6, or 216. And when I go ahead and put those in, I'm going to get my final solution, which I already calculated this morning, so I don't want to calculate it again because I'm lazy. So that's 5,184 units cubed. So if it took me 24 actual physical blocks to build it, if I wanted to make it 6 times bigger, I would need more than 5,000 blocks just to build it. That's because every single block I would have to be, I would need 216 blocks for every 1 block I had before, because my scale factor is 6. And then my surface area, it's going to be very similar. I'm going to take my original surface area, which was 86, and the units were squared. I'm going to find so this is my old surface area. My new surface area is going to be 86 times the scale factor squared. And the scale factor is 6, so that's 36 times 86. And when I multiply those, my new surface area is 3,096 units squared. All right. Now on the test, you will have to be able to put in words what your technique was for getting these answers. So you not only have to show your work and show how you got your calculations. So what I don't want to see is just 24 times 216, because then I'm going to wonder, where did that 216 come from? I need you to show me clearly exactly how to get those things done. Now, on this other side of the team test, what we're going to do is we're going to talk about this one. Unfortunately, I only have one copy of this, or two copies, one for my lesson I'm giving later. I guess I should have used a less leaky pen, but oh well. So what we're going to do is we're going to go over this proof together. Now, the idea about this is, if you know some of the simple things, it should actually be not too difficult. But you do have to be on the lookout for those simple things. You may have trouble doing the more difficult things, but you probably should be able to get at least 60 or 70 or so percent just by remembering some of the simple things. For example, it says here that E is the midpoint of AC. Well, they tell us that right here. So all we have to write is given, and now we have 60% on this side of the test. The next one, they tell us the reason, and then we have to figure out what to put in the spaces. Now, we're trying to prove that this triangle is congruent to this triangle. Since those are the triangles we're trying to prove are congruent, we're going to look for vertical angles within those two triangles. So I'm going to go ahead and mark them right here. Now that I've marked them, I want to name them out, and I must use 3 letters. So I'm going to trace it out. A, E, B, and write that here. A, E, B. And then I'm going to trace this one out. C, E, D. So if you can get that, now you have 70% on this test. Now the next part, it's over here. We begin by knowing that these two segments are parallel. Now we learned way back in, I think it was chapter 2 or 3, all about parallel lines. And we learned that when we have parallel lines, we have angles that are congruent. Like these would be congruent because they're alternate interior angles. They're congruent when the lines are parallel. So now I have to name them, and again I have to use 3 letters. BAE is congruent to DCE. And then the next one over here, 6.4a. I think 6.4b got lost. I was going to have you do this, but I decided that you didn't have to and forgot to change this to b. I apologize. But the next one is over here. Why are these two segments congruent? So if I look here, it says E is the midpoint of AC. And the next thing they say is that these two segments are congruent. So I'm going to go ahead and mark it on the diagram, but I have to figure out why those two would be congruent. Well, all I have is that there's a midpoint, and suddenly segments are congruent. Well, that's the definition of a midpoint. Remember, if you find yourself saying because it's a midpoint, as soon as you say the word because, it means it's probably some kind of definition. So I wanted to kind of give you that heads up. And then here we have to come up with a reason for these two triangles to be congruent. Well, when I look at this one, I see that it has this angle congruent to that one. So I picked this one to work with. This side is congruent to this side, and this angle is congruent to this angle. Whenever I have two angles and a side, it's always going to work, but I have to figure out which of these two methods it is. Is it the one where the two angles touch the side, or does the side only touch one of the angles? But when I look here, this side comes into contact with both of those symbols. So it has to be angle, side, angle. Now the only thing I have left to do is to fill in my 2-column proof with everything that's in the flow chart. So I began here. That's where I'm going to start over here. E is the midpoint of AC. And I think what I'm going to do, because my handwriting isn't so good, I went ahead and I'm going to put the actual proof up on the screen for you from my computer so you can follow that yourself. But one of the biggest things is to make sure, like, all 3 of these sets of arrows come to this point. So I have to put this one, then this one. Then I have to have these 2. And then I have to have this and this and this. So I'm going to show you and allow you to look at this as the solution. It's better than me writing it all out. So you're going to spin around and around and around until I give you this high-tech view of the final proof. So let's see if I can make it stabilize so I can talk about it. All right. So notice how we begin with E being the midpoint of AC, and I'm going to follow the arrow from that one on your paper down to where it says that the 2 segments are congruent, and then I put the reason. The next thing I'm going to do, because I can't do that final bubble till I have all the arrows leading to it, I go up to the next one, which is vertical angles, and then the 3rd set of bubbles with the parallel sides and the sides that, and the angles that are congruent. So I try to make sure to have everything as organized in the same order as on the flow chart as possible. So all of the arrows are going to lead to one final bubble. That should always be the one that's on the bottom. And the bubbles are the statements, and the reasons are the boxes underneath. So I hope this has helped. I apologize for the low tech, but I'm trying to do everything I can to help you guys to make through successfully. If you are planning to work on the test and there's something about this video that you find confusing, you can send me, you can put a note in the Google Classroom. I will get back to you as soon as I see that. I do check my email frequently throughout the weekend. My computer will make a noise every single time you send me a comment. That's why I try to respond as soon as possible if I'm awake. When I'm asleep, I am not responding. So good luck on the test. Remember, this is something that we want you to be successful on. So just keep that in mind. We're trying to do everything we can to help you to be successful.